we begin our examination of the history of life on Earth by addressing a fundamental misconception that permeates the popular understanding of deep time. It is the prevailing narrative that the history of the Earth is divided into distinct, non-overlapping chapters, that there was an age of reptiles, followed by a sudden cataclysm, which then gave rise to the age of mammals. This view suggests that the demise of one group was a prerequisite for the emergence of the other. However, as we analyze the dialogue between the physicist Alexei Semikhatov and the paleontologist Pavel Skuchas, we are compelled to construct a far more complex, intertwined, and dramatic reality. We must understand that the biological lineage that led to humanity did not merely succeed the dinosaurs. It was forged by them. The evolutionary trajectory of mammals was sculpted by the intense pressure of living in the shadow of the dinosaurs for hundreds of millions of years. To understand this relationship, we must first dismantle the myth that dinosaurs are entirely extinct. While it is true that the non-avian giants, the tyrannosaurs, the sauropods, the ceratopsians, vanished from the fossil record approximately 66 million years ago, the lineage itself persisted. As Professor Skuchas elucidates, the rigid binary between extinct and extant is scientifically inaccurate in this context. Birds are not merely descendants of dinosaurs. They are, in cladistic terms, dinosaurs. They are the surviving lineage of theropod dinosaurs that endured the Great Extinction event. Therefore, when we look at the modern world, we are looking at a biosphere where dinosaurs and mammals continue to coexist, continue to compete, and continue to occupy the planet together. This realization forces us to re-evaluate the entire narrative of our own origins. Let us cast our minds back, not to the end of the Cretaceous period, but to the very beginning of this saga. We must look to the Carboniferous period, long before the first dinosaur or the first true mammal walked the Earth. It was during this time that a momentous biological innovation occurred, the emergence of the amniotes. Before this development, vertebrates were largely tethered to aquatic environments. Amphibians, though capable of moving on land, were bound to water for reproduction. Their eggs, gelatinous and permeable, would desiccate if exposed to the harsh air. They passed through a larval stage, the tadpole, requiring an aqueous medium to develop. The ancestors of both dinosaurs and mammals broke these chains through the evolution of the amniotic egg. This was a self-contained life support system, a capsule enclosed by a semi-permeable shell that allowed for the exchange of oxygen and carbon dioxide while retaining essential moisture. Inside this egg, a series of membranes, the amnion, the chorion, and the allantois, replicated the aquatic environment, allowing the embryo to develop in a personal, portable pond. This innovation was accompanied by the development of keratinized skin, scales, or thickened integument that prevented dehydration, and the evolution of more efficient pulmonary respiration, negating the need for cutaneous breathing, which requires moist skin. From this ancestral amniote stock, the tree of life bifurcated into two distinct and diverging branches. One branch, the Sauropsida, would lead to modern reptiles including turtles, lizards, snakes, crocodiles, and eventually the dinosaurs and birds. The other branch, the Synapsida, would lead to the pelycosaurs, the therapsids, and eventually the mammals. It is crucial to internalize this timeline. The separation between the line that led to Tyrannosaurus rex and the line that led to Homo sapiens occurred over 300 million years ago. We are cousins, separated by a vast chasm of time, yet originating from the same foundational biological breakthrough. We move now to the Triassic period, approximately 230 million years ago. This is the stage upon which the great drama of competition began. The fossil record from this era is, as is often the case in paleontology, fragmented and incomplete. We do not have a continuous day-by-day account of the transition. Rather, we have snapshots, windows into deep time provided by specific geological formations that happen to have preserved the bones of the dead. Yet, these snapshots tell a consistent story. The emergence of the first true dinosaurs and the emergence of the first true mammal-like forms occurred almost simultaneously. It is a common error to imagine that mammals were a late addition to the Mesozoic world, appearing only after the dinosaurs had established their dominion. The reality is that the ancestors of mammals, the synapsids, were the dominant land animals long before the dinosaurs rose to power. During the Permian period prior to the Triassic, the land was ruled by these mammal-like reptiles. These were not small, shivering creatures hiding in the dark. They were magnificent, diverse, and often gigantic. They ranged in size from small, lizard-like insectivores to massive herbivores the size of elephants, and apex predators the size of tigers and bears. They were the masters of their world. However, the Permian period ended with the most catastrophic extinction event in Earth's history, the Great Dying. This event, likely triggered by massive volcanic activity in what is now Siberia, altered the climate and chemistry of the planet so radically that the vast majority of life was extinguished. The ecosystems were shattered. The slate was wiped nearly clean. It was in the recovering world of the Triassic that the balance of power shifted. The synapsids, though they survived the extinction, were diminished. Into this ecological vacuum stepped a new group of reptiles, the archosaurs, the ruling reptiles, from which dinosaurs emerged. These early dinosaurs represented a new paradigm in biological engineering. They were distinct from their sprawling reptilian ancestors. They developed a bipedal stance, with legs positioned directly under their bodies rather than splayed to the sides. This anatomical adjustment allowed for greater speed, agility, and endurance. Furthermore, there is growing evidence, alluded to by Professor Scuccias, that these early dinosaurs were already experimenting with endothermy, warm-bloodedness. They possessed high metabolic rates, efficient respiratory systems likely involving air sacs similar to those of modern birds, and perhaps even primitive insulation in the form of protofeathers. The collision between the recovering synapsid population, our ancestors, and this rising tide of dinosaurian competitors was a turning point in the history of life. The dinosaurs were faster. They were more efficient predators. They grew to larger sizes more rapidly. The large, lumbering synapsid herbivores and carnivores found themselves outclassed by these terrible lizards. This was not a passive replacement. It was a competitive displacement. The dinosaurs exerted a tremendous evolutionary pressure on the synapsids. This brings us to the core thesis presented by the researchers. The dinosaurs, by their very dominance, forced the ancestors of mammals to fundamentally change their nature. This process can be described as the mammalian bottleneck. To survive in a world swarming with agile, visual, diurnal dinosaur predators, the ancestors of mammals had only two choices: adapt or perish. They could not compete with dinosaurs in terms of size. A large mammal-like reptile was simply a large meal for a theropod dinosaur. They could not compete in the open daylight, where the dinosaur's keen vision gave them the advantage. And so, under the relentless gaze of the dinosaurs, our ancestors shrank. The evolutionary lineages of the synapsids that retained large body sizes were systematically hunted to extinction or outcompeted for resources. The only lineage that survived was the one that retreated into the micro-world. Over millions of years, the ancestors of mammals became smaller and smaller, eventually reaching sizes comparable to shrews and mice. They abandoned the day. They became creatures of the night, hiding in burrows, navigating the root systems, and emerging only under the cover of darkness to forage for insects and small invertebrates. This miniaturization and shift to nocturnal habits was not merely a change in behavior. It necessitated a complete biological overhaul, an overhaul that defines what it means to be a mammal today. Because they lived in the dark, they could no longer rely on vision as their primary sense. Consequently, the mammalian brain began to rewire itself. The areas of the brain dedicated to processing auditory and olfactory information, hearing and smell, expanded dramatically. The intricate structure of the mammalian middle ear, with its 3 tiny bones derived from the reptilian jaw, evolved to detect the faint, high-frequency sounds of insects and approaching predators in the gloom. The sense of smell became acute, a chemical radar in the blackness. Simultaneously, the need to navigate without light led to the development of the vibrissae, the whiskers. These are not merely hairs. They are sophisticated tactile sensors, deeply rooted in the skin and connected to a rich network of nerves, allowing the animal to build a spatial map of its immediate surroundings through touch. To maintain a high body temperature in the cool of the night, and in their small bodies which lose heat rapidly, they developed a coat of fur, insulation to retain metabolic heat. This high metabolism required constant fueling, driving the efficiency of their digestion and dentition. Even our vision bears the scars of this era. Most reptiles and birds possess tetrachromatic vision. They see the world in 4 color channels, including ultraviolet. Mammals, however, largely lost this ability during their long tenure in the dark. The ancestors of placental mammals lost 2 of their 4 cone types. We humans partially regained a 3rd cone much later in our primate evolution, but we still lack the visual richness of a bird or a turtle. This is a direct legacy of the time when our ancestors lived in the shadowy underground, suppressed by the tyranny of the dinosaurs. Thus, we arrive at a profound realization. If not for the dinosaurs, the class Mammalia as we know it would likely not exist. The specific suite of traits that characterizes us, endothermy, fur, acute hearing, complex teeth, large brains relative to body size, was forged in the crucible of dinosaurian dominance. We are the product of resistance. We are the descendants of the survivors who endured a siege that lasted for over 150 million years. The dinosaurs did not merely allow us to exist by dying, they created us by living. For the entirety of the Jurassic and Cretaceous periods, this status quo remained largely unchanged. Dinosaurs ruled the meganiches. They were the large herbivores, the large carnivores, the dominant life forms on land. Mammals ruled the microniches. They were the insectivores, the scavengers, the small omnivores. While it is a simplification to say all Mesozoic mammals were tiny, some did reach the size of badgers or small dogs, and there is even evidence, such as the fossil Repenomamus, of a large mammal feeding on juvenile dinosaurs. Broadly speaking, the ecological ceiling for mammals was very low. The dinosaurs prevented mammals from evolving into large-bodied forms. Then came the second great pivot point in this history, the celestial intervention. 66 million years ago, a rock, An asteroid approximately 10 to 15 kilometers in diameter intersected the orbit of the Earth. It struck the planet in what is now the Yucatan Peninsula of Mexico. The energy released was equivalent to billions of atomic bombs. The impact was not merely a local disaster. It was a global engine of destruction. The initial blast wave and the heat pulse incinerated everything within a radius of thousands of kilometers. But the true killer was the aftermath. The impact ejected trillions of tons of rock, dust, and sulfur into the upper atmosphere. This debris formed a global shroud, blocking the light of the sun. Photosynthesis, the foundation of the biological energy cycle, halted. Plants died. The food chains collapsed. The temperature plummeted. In this darkened, starving world, size was a death sentence. The great dinosaurs, with their massive caloric requirements, could not sustain themselves. They were specialized for a world of abundance, and that world had vanished. The ecosystems that supported the Triceratops and the Tyrannosaurus disintegrated. However, the mammals had spent the last 150 million years preparing for exactly this nightmare. They were small. They did not require vast amounts of food to survive. They were omnivorous and adaptable, capable of eating insects, roots, decaying matter, whatever was available. Crucially, they were burrowers. They lived underground, shielded from the initial heat and fires. They were nocturnal, pre-adapted to a world of darkness. The very traits that the dinosaurs had forced upon them became the keys to their survival. When the dust finally settled and the sun returned to a scarred Earth, the giants were gone. The non-avian dinosaurs had been wiped from the face of the planet. The skies were empty of pterosaurs. The seas were emptied of the great marine reptiles. But the mammals, along with the birds, crocodiles, turtles, and amphibians, emerged from their shelters. For the first time in hundreds of millions of years, the world was open. The ecological constraints were removed. The forests and plains, now regenerating, were devoid of large browsers and grazers. There were no large predators to stalk the open spaces. The survivors looked out upon a planet that was, effectively, a vacant lot waiting to be built upon. The evolution of mammals in the Paleogene period, immediately following the extinction, was explosive. Released from the suppression of the dinosaurs, mammals began to grow. They radiated into the empty niches. Within a few million years, mammals had evolved into large herbivores, swift predators, swimmers, and climbers. They took the forms that we recognize today, the ancestors of horses, whales, bats, and primates. This rapid diversification, this sudden claiming of the Earth, was only possible because the previous tenants had been evicted. Yet, we must not forget the birds. As mentioned, birds are dinosaurs. They are the lineage of small, feathered theropods that survived the asteroid impact, likely due to a combination of their small size, their ability to fly. In the immediate aftermath of the extinction, there was a brief period where it seemed that the dinosaurs might reclaim their throne. Large, flightless predatory birds, the terror birds, evolved in places like South America, becoming the apex predators and hunting the early mammals. It was a faint echo of the Mesozoic, a reminder of the ancient rivalry. But eventually, mammals outcompeted these avian rivals in most ecosystems, solidifying the Cenozoic era as the Age of Mammals. It is interesting to reflect on the contingency of our existence. If that asteroid had missed the Earth, a matter of orbital mechanics, a difference of a few minutes in arrival time, the non-avian dinosaurs would likely have continued to reign. There is no inevitable internal mechanism that would have doomed them without external interference. They were successful, diverse, and adaptable. If the asteroid had passed us by, mammals would likely have remained small, nocturnal creatures, scurrying in the undergrowth. There would be no elephants, no whales, and certainly no humans. We would not be here to discuss this history. Intelligence of a human level might never have emerged, or it might have emerged in a completely different lineage, perhaps within the dinosaurs themselves, though that is pure speculation. Today, we look around and see a world dominated by humans, a species of mammal. But biologically, we are vastly outnumbered. If we count species, the dinosaurs are incredibly successful, with over 10,000 distinct species compared to roughly 6,000 species of mammals. In terms of pure diversity, one could argue it is still their world. We occupy the meganiches, but they occupy the skies and every tree branch. The relationship between dinosaurs and mammals is not a simple story of succession. It is a story of coevolution, of deep interaction, of a rivalry that shaped the very biological essence of who we are. We carry the legacy of the dinosaurs in our anatomy, in our senses, and in our history. They were the architects of our ancestors' tribulation, and by forcing us into the shadows, they inadvertently honed the tools that would allow us to inherit the earth when the stars fell. The history of life is a continuum, a single, unbroken stream of genetic information flowing through time, shaped by the landscape of geology and the interactions of its inhabitants. We are the current stewards of this legacy, looking back at the terrible lizards, not just as monsters of the past, but as the rigorous shapers of our own creation. This concludes our detailed examination of the evolutionary dynamic between dinosaurs and mammals, as derived from the discussion between Alexei Semikhatov and Pavel Skuchas. The flow of time, the pressure of predation, the catastrophic intervention of the cosmos, and the resilience of life have all conspired to produce the biological reality we inhabit today.